Hey, what's up, Internet? So, AI companies are burning billions of dollars right now, and there's a strategic reason to this madness. In today's video, I want to walk you through Mary Meeker's recent report. This is a report all about AI, 340 slides. And if you don't know who Mary Meeker is, she's kind of the queen of the internet. She used to have a report that she would put out every year, and it would move markets, it would move VC money. And she took a hiatus for 5 years, and she's recently returned with this AI focused report. Like I said, this is 340 slides. I went through every single page. I distilled it down just to the 25 insights that I think are the most interesting, and I bucketed those into four categories. And if you're interested in getting a distillation of the most important points from this report, let's dive in. All right. As always, we have ourselves a beautiful image from OpenAI. This is, I think, a good representation of how I felt after reading this report. Let me explain. When you go to, say, a museum with a lot of beautiful art, you tend to get desensitized to the beauty over time. For me, it takes roughly 55 minutes, and then all the beauty starts to kind of get saturated in a sense, and all my senses are, uh, I would say, dampened or dulled. So it's hard for me to actually appreciate the art in front of me. And the same thing happened with this report. Reason being is in this report, unprecedented, the term unprecedented, it's hard to say. That term was mentioned probably like 55 times or something like that. Reason being is all of the charts inside of this presentation look like this or this. So either everything is growing rapidly or everything is declining in price rapidly. So overall, AI in itself is a technology that's changing everything so quickly that everything is abnormal. In that sense, most of society will have to adapt to what that means to be normal in the future. Because if we're going to adopt this technology and utilize it and it's going to rapidly change everything, our perception of what normal is will change. So that's kind of the premise of this picture and what I took away from here. Like I said earlier, we have four categories. The first category here over here is going to be about expansion, instant expansion. Second category is about the paradox of economics specifically. Then we'll talk about infrastructure and the build out for the hardware stuff. And then last is miscellaneous. So that's kind of just surprise slides that I found useful. So we'll start with instant expansion. Now, this subset of graphs, so the next four graphs, I would say encapsulate the benefit that OpenAI is getting from the internet. So having access to something that's been built by others and utilizing that to your own benefit is something that we're going to see here. In this first chart here, is depicting OpenAI's ability to get to the same number of users outside of the United States compared to the internet. And they were able to do it in 3 years. The internet took roughly 23 years. And remember, I want to quickly remember that this is outside of North America, not inside of America. Either way, that's a massive ramp up in timing for their ability to get that many users in that time frame. So 90%. That's our first chart. The next one here is again, like I said, everything is basically up and to the right. And it's not just like a hockey stick, but it's like basically a vertical line, which is crazy to see. And this is number of users, number of subscribers, so people paying them, and their overall revenue. And this is between 2022 and 2024, so 2 years. And here, this is my addition. So this isn't in the actual report. I've just added this. Reason being is that right around March of 2025 is when the image gen was released for 4.0. And it's interesting to see that a visual tool, so something that creates images, basically enabled OpenAI to double all of their stuff. So users, subscribers, and revenue. Not all, but most. That for me is impressive because it's just one feature of many things that this tool can do to benefit people's both work and life. And just the fact that you can visually see something and play with images ramped up their ability to get more users. So that's the second chart for growth. Our third is similar to the first, but instead of comparing OpenAI to the internet, we're comparing OpenAI to Google. And here we have OpenAI achieving the same thing Google achieved within 2 years instead of 11. So 11 years for Google, 2 years for OpenAI. And what this is searches. So how many searches a user is doing. And OpenAI was able to get to the same number of searches in 2 years instead of 11. But again, this is because OpenAI is leveraging the infrastructure that's been built before it. So it's getting the benefits of its forebears. So it's a 5.5x faster than Google. That's our third chart. And then our last one here is around revenue or no users. So this is basically how fast can you get to 100 million users? And OpenAI was able to achieve this in 2 months. So that's what point two stands for. And everybody else took much longer. And even the best of the best. So we have TikTok, Fortnite, and Disney Plus is a surprise to me, but it's up there. And you can see they were all able to achieve 1 million users, but probably 3 to 4x slower than OpenAI, or at least ChatGPT, the product they've released. So these I'd say these four charts here, I would say encapsulate the idea of building on the shoulder of giants. I think is like the whole analogy, and that's what's happening here. Is they were able to utilize the internet and previous existing technologies to instantly expand not just the number of users, but the diversity of users geographically with their products and their tools. And that's one benefit we're seeing with this tool, and we'll likely see with many other AI tools in the future, based off of the infrastructure people can use. So that's our first insight or trend. Our next one here is the paradox. So there's a few paradoxes here. Paradoxes. We have economic and Jevons paradox. So we'll start with economic. And I guess before I get into these, I'll try to explain my thought process here. So I picture this as a stool. So we have three legs to the stool. One leg is cost for spending. So this is how expensive something is. So we'll do an arrow up. The other one is the cost of how cheap things are. So like kind of arrow down. And then the last one is usage. So we'll do usage. We'll do like a U for an arrow up. So these three legs of this tool. So things are getting more expensive to train, but to serve them, it's getting cheaper, which means more users are going to use it. So that's kind of the three legs tool idea I have here. We'll start with the first chart. Alrighty. So our first chart here is showing how expensive it is to train a model. We're starting back in 2016-ish, and we're going up to around 2025-ish. And here you can see there's roughly a 2,400x. So this isn't percent, this is x. So that's a huge jump in how expensive it is to train these models. And there's many reasons as to why, the amount of data, the amount of computers, and all of the amount of parameters, etc. But with more expensive training comes higher quality models. So they're more intelligent, they're more useful, and we humans we can use these for actual practical tasks. So that's on the expense side. So that's kind of expensive. The next thing is the drop in expense. Now this chart is showing the consumption of energy per token. So how much energy does it take me to serve you an answer? And I'll give a quick. I guess probably should do a definition here. So what I'm talking about training. I'm talking about inference. So we'll just do inf for inference. So over here, the stuff I just talked about was training. So that's when you train your model prior to serving it to your users. So that's when you basically grow the intelligence of the model before it's readily accessible for other people in the world. Once you've trained it and you've made it smart, then when you serve it to people in the world, that's the inference piece. So you're giving answers out to people that are asking questions, or you're doing things on behalf of people that are asking you to do things. That's the inference people. You're serving stuff to people. And that's this side here. So that's the inference side. And that's when we're talking about the energy costs. So this here is a variety of different chips that have been given or shipped by NVIDIA. And you can see this is by far, for me, the biggest number that I've seen in this entire deck, which is a huge kudos to this chart because I've seen some massive numbers here. And this is a decline, 105,000x, not percent, but x. That's a huge percentage drop in the amount of energy that's emitted per token. And it's basically gotten to zero for Blackwell. And what that means is it costs us almost zero energy to serve one token to somebody, close to zero, not zero, but close to zero, one token for somebody. So that means it's almost zero energy to serve an answer to somebody. That's this chart here. And then this is just another way of looking at that specific data set. So right, the previous one we just looked at, so the one over here, that was talking about chips. Now this one is going to talk about models. So here we have the price of inference. So how much does it cost for me to infer a given answer? And then that's linked to different models released over time. So you can see GPT 3.5, one of the earliest, was quite expensive. So it cost quite a bit of money for it to give me an answer. But if we go forward here in time, we can see that models that are way smarter, Gemini 1.5 Flash, way smarter than Gemini 3.5, it was able to provide a better answer at a much lower cost. And even those higher end models that are more expensive, such as Sonnet 3.5 and others right now, they're still cheaper than previous models based off of the infrastructure, the advancements we made in these models and inference, etc. So that's a 10x price change. So that's the costs, right? So these are the this is the economics, the money associated to this. Now next is usage. Well, almost, I lied. This is another one. This is another one on cost, but this chart is a bit convoluted, so it'll take some time to explain. But the premise here is that as the models, as the cost of maintaining the infrastructure for these models declines, the size and intelligence of the models increases. So what do these axes mean? So this axis here is talking about flops. What is a flop? It's a weird term. It's basically how many computational cycles a computer can go through within a set time frame. The faster a computer can go through these computational cycles, the more flops it can do within a certain time frame. That's the premise of this axis. So these models over here can do tons and tons of flops, meaning that they're likely more and more intelligent and a lot bigger. And then over here, this is the time axis, and we're showing that the amount of money it takes to maintain the overall infrastructure associated to these systems has declined drastically. So much so that it's gone down from 100 or so down to below 10. And that's a massive drop in price associated to maintaining these. Now, this is where we get into usage. So, since these systems and these AI models are so intelligent and they're so cheap to serve answers with, that means more people are going to use them because they can get more use out of them at a reasonable price. And that's where this number comes from. We have a 50x monthly increase in the number of tokens being processed by Google associated to its models. So, only a year ago, they were serving about 10 trillion tokens. So, a token is basically a part of a word, meaning an AI says something to you, that's a number of tokens that it speaks out. So they're at 10 trillion in last year of 2024. But this year of 2024, they 50x'd that, and now they're at 480 trillion. That's a massive number of tokens. And my guess is that it's only going to increase. So we're going to see another massive jump in 2026, probably maybe even bigger than 50x, based off of the usage for these tools and also the types of models and etc. So that is the usage piece there. Now, the question that I want to ask myself, and a lot of people want to ask themselves, is who benefits from this? So, who benefits from all this spending? Because at the beginning, I talked to you about the fact that all these companies are burning billions of dollars, but they're doing it for a purpose. And the purpose they're doing it for, and let me kind of go up here to explain that, is they're doing this to ensure that they can win this race. So, the race is not just against each other. So, it's against a bunch of AI companies in the US, but it's also against AI companies around the world, in China and other locations. And the race is to whoever can get to artificial general intelligence first, but also whoever can gather the most consumers, the most data, the most infrastructure to then train those models. All these different variables are critical for them to get to that endpoint, that overall goal of AGI. And they're all racing and they're burning money to do that. And they're okay with doing that because the end goal is so beneficial that they can burn billions today to make trillions tomorrow. Which sounds crazy, but it's it's looking pretty realistic. But the question here is who's benefiting? Well, right now, if we look at these charts, we can see clearly that Nvidia is basically the not the sole person winning, but they're definitely they're winning pretty hard right now. This chart here shows that, and there's another chart over there that shows it as well. So this one here is showing the capex spend for data centers and the associated revenue for NVIDIA. This is capex. The blue bars here, 2022, 2023, and 2024, is the global spend for data centers and capex. And the red line here is the revenue for NVIDIA. So you can see basically all the money that these individuals are spending on these data centers. Roughly 25% of that is getting dropped right into NVIDIA's pocket. So that's great for them. This is just a more stark version of that, this chart here. This is the big six technology companies, their R&D costs and their CapEx cost. And this is NVIDIA's revenue. And there's a direct correlation between their revenue, so the revenue is the red line, and the blue bars is their spend on R&D and CapEx. So a lot of the money these big six technologies is spending, they're spending it on these chips and the infrastructure associated from NVIDIA. So they're the winners today. The question that we should ask ourselves is who's the winner for tomorrow? And this is the question that a lot of venture capitalists and startups are trying to answer. And my vote at the moment is likely going to be the application layer. So it's not necessarily the infrastructure or even the foundational model layer. It's going to be the applications built on top of that that provide direct value to consumers and businesses, similar to how other things have played out in the past. So that's my bet, but only time will tell. And that is our paradox. Next, we're going to talk about infrastructure. So this is the biggest infrastructure project ever that we've ever experienced and will likely continue to be the biggest and continue to change the definition of big. So this first chart here is showing the megawatts for data centers. So how much energy can a data center consume and utilize? This blue chart here, this blue line, is the existing capacity. So how much energy can we utilize for these data centers? And when I say data centers, I should probably say AI factory instead, because this isn't a data center. This is basically an intelligence factory. So an AI factory where you're pumping out intelligence. So we've 5x'd our ability from 2020 to 2024. We 5x'd our ability to both consume and produce energy and convert that into intelligence. Now, for the next 4 years, so in 4 years, we'll have 16x'd that 5x, which is good progress, but it's still not ideal and not enough. The good news is we're making progress in our ability to build these factories, and fingers crossed, hopefully the energy to kind of fuel them as well. So this chart here, I think is probably one of the most interesting because of the contrast between these two images and the statistics associated. So what you're looking at here in this image is Colossus. So this is XAI's massive AI factory, Elon Musk's company XAI. They were able to build this factory in 122 days. And this factory contained 100,000 GPUs to run their kind of Colossus AI network. After 122 days, they added another 100,000 onto that in only 92 days. That's way faster than any other type of factory of this size because usually it takes years. Now, the stark contrast here is that building a home in the United States takes roughly 234 days. So you could build roughly half of a home in the US for the same time you can build a Colossus massive factory. And the home is only around 2,000 square feet, while the Colossus is almost 750,000. So it's a huge stark contrast between what can be built when urgency is in tail, when there's a lot of urgency around building AI and the importance of this, and the red tape and the associated bureaucracies around building homes. So that is our infrastructure project. Below this, I want to talk about energy as well, because energy, if you research any of this stuff as of today, you'll see that energy by far is the most important thing. I would say probably it is the most important thing when it comes to AI. If you look at China, America, etc., the country that will likely win will be the one that can produce the most energy in the shortest amount of time to fuel these AI factories to create intelligence faster and to learn from the process of creating intelligence faster. And if you look at these charts here, we'll look at consumption and then production. So first, we have consumption. The US has always been one of the biggest consumers of electricity for many use cases, but one of which is the consumption for these massive data centers. And you can see they've broken this down by two different things. One is the type of factory or type of data center, and then the type of stuff inside of that data center. So on this side, we have enterprise, hyperscale, and coalition factories or AI factories or data centers. And on the other side, we have the different items inside of the data center. So we have servers, we have cooling, and then we have other IT and other infrastructure. My guess is that cooling is going to probably grow quite a bit, and servers is going to grow quite a bit as well. On this side, for hyperscalers and enterprise, my guess is that hyperscalers are just going to get massive because we're going to have a bunch of mega AI factories. So another way we can look at this consumption is by region. So here, like I said, America tends to consume the most. My guess is China will likely expand and maybe even take over America and how much energy it's consuming based off of these factories. If that's true, that stays consistent. I don't know, but it's a guess. But this is consumption. One chart that was missing from this report, sadly, and I really wish it would be included because I think more people need to see this and understand this, is the generation of electricity. So, how much energy can one country generate as of today? Well, back in 2010, China surpassed America's ability to generate energy and electricity. And if we look at this chart, we can see every single year, China is adding an entire United States worth of electricity onto its grid. And that's what each one of these dots are associated with. So each of these dots are showing how much energy is being added to the Chinese infrastructure for them to then generate in the future. And you can see the US is very static. This is not great for the US and it's amazing for China. I'm glad that China is doing this. I wish that the US would, do one of these. No idea if they will, but fingers crossed that we'll be able to generate more electricity for the AI that we need for the future of both America, but also humanity. All right, after that deep philosophical conversation, let's go to the surprise slides. So these are kind of the miscellaneous things that I found interesting. The first few are going to be around adoption. So who's using this and how often are they using it? The big thing for me is I was surprised by how few people are using AI in general. This first slide here is talking about who has ever used ChatGPT. So in the United States, have you ever used ChatGPT? On average, for all US adults, only 37% of people have ever used ChatGPT. The best case here, between 18 and 29, is only 55%. That for me was a genuine shock. I was surprised by how few people are using this tech. And the next one is, even I would say in my head even more stark, where it's not just who has ever used it, but also how often they're using it. So this one is daily minutes utilizing ChatGPT, and the max is 20 minutes. So sure, it's a 200% increase. That's great. But in my head, 20 minutes a day for ChatGPT is really low, especially if you know how to get the most out of these tools. There's a huge gap between what people can get from these tools today and what they're actually getting from these tools today. There's a massive delta between those two, and that's a really surprise to me. I thought it would be more than 20 minutes. And then the next one here is a similar thing around usage. So here we're looking at average per minutes per session, so how long they're spending per session and how many sessions per day. So here they have at a max 9 and 3. So 3 minutes, it's not even 3 minutes. So it's like kind of, so what is this? Like a little over 2 minutes per session. And then for the number of sessions, it's like maxing out at 8. That for me again is very low. I think it's because I live in a bubble, and being in a bubble, I'm surrounded by a bunch of people that are obsessed with AI, that are in the valley, etc., and they're using these tools day in and day out, probably 4 to 5 hours a day. And this for me is just a great reminder of how many people aren't utilizing these tools enough, and the importance of doing stuff like this, and also talking to people all around the world and in the country to understand how they can use it more effectively. All right, so that was our adoption few slides. Now this one is around the convergence of intelligence. Now, I'm not convinced that this is actually true, but I did want to highlight it because it is quite interesting. So here we have 2024 February. There's a massive gap in intelligence. So this axis here is the LM-SIS arena. So this is one way to measure intelligence for AI, and you can see there's a big gap between the different models. But if you zoom forward as of close to today, you can see there's a massive convergence of intelligence. All the models are getting of a similar intelligence, and it's almost like they're peaking. But part of the reason I disagree with this measurement is that LM Arena is a good benchmark. I agree, but it's just one benchmark of many. And as these models get more advanced and they start to diversify in their abilities, such as Claude with code, Gemini with video generation, there's different multimodality use cases that are more useful for different use cases in real world. So not benchmarks that are theoretical or artificial, but things that are people are using these models, to do their jobs and to live their lives. So I'm not fully convinced by this measurement, but it's one way of measuring. Now, this next one here is around companies. So, company growth specifically. This red line here is representing SaaS companies, so the top 100 SaaS companies. And the blue line is the top 100 AI companies. Now, what you're looking at is the delta between how long it takes them to get to, what is it, 5 million? Yeah, 5 million in ARR. And here it took 24 months for the top 100 AI companies to get to it and 37 months for SaaS companies. So this just shows you how quickly people are monetizing and getting value from these tools to pay for, and the speed at which they can do that. My guess is the expectations that investors will have, so venture capitalists and other groups, they'll have expectations for companies to compress this time frame even further. They're likely going to hope that AI companies, can do one of these, where only in a few months you're able to get to 5 million in ARR because of the tool that you're providing is so drastically valuable and different that everybody's going to want to purchase it within that niche that you're serving. My guess is that that will continue. That time frame will shrink. All right, so we have two more categories here. This next category is around model preference. So this is website visits. So how many times has a user visited your website? They're using SimilarWeb to kind of dictate what this is. And here you can see, which is surprising to me, DeepSeek is by far and above the other three. So it's not showing OpenAI. So OpenAI is going to obviously be like way up here. Gemini's not here. My guess is Gemini actually wouldn't be too high up. Maybe it's like around here, maybe. I have no idea. My guess is that it's going to get higher because of all the new things releasing, but they're probably around there. The one thing that surprised me that I wanted to share with you is Claude. So you can see Claude is last. And I'm guessing if they were tracking API calls and the associated token usage for APIs, Claude would be a lot higher because it's mainly used for generating code for developers. But when looking at this, you can see that it's still drastically low. And for me, that's a surprise because Claude is very useful for more than just coding, for writing and a variety of other things. So I guess the surprise to me is that the quality of the model does not directly associate with the number of visits or users they have. That's an obvious thing to say. A lot of people know that, but this is just a vivid way to see that and it manifesting in reality. Another cool thing to call out is you can see that DeepSeek is quite high up here. So DeepSeek is beating many of these models, Grok, Perplexity, and Claude. The reason being is that most users are based in China and or India. So there's other slides inside of this presentation that show you the percentage breakdown of market share. And DeepSeek has the majority of the market in China, obviously, and a good proportion of India. And that just shows you how diverse the users are and how rapidly that diversity has increased in such a really tight time frame. And this is just another way of looking at that same data set. So instead of looking at website visits, we're looking at share of consumer users. So how many users are using your tool and the overall market share. And OpenAI is by far winning, as always, or not always, but for now. Gemini is putting up a good fight in second. And then the one thing I wanted to show you here again is DeepSeek. So DeepSeek is again above Grok, Perplexity, and Claude. And sad again, Claude is so low. I think it should be a lot higher, but it's not. And that is the category here for, category for adoption and usage. And then our last category is on open source. Now, the premise of this chart, I'm pretty sure that Mary was going to try to explain the fact that there's a lag between closed source and open source. So open source is the blue line, closed source, orange line. Now, what you're looking at here is flops. So basically, training compute. So how it's an approximation of intelligence. So how many flops a model kind of has been trained on, et cetera, and then the publication date. The point here is showing that there's a gap between closed and open source, and the number of flops needed to train the models that are closed source are much larger than those in open source. So there's a 17-month lag in how much compute is being used to train open source models. The part of the argument Mary is making here is that open source models are catching up, but they're cheaper, so they're both equal intelligence and cheaper to train. I kind of disagree with that, partly because a lot of the DeepSeek points around them being so cheap to train has been somewhat debunked. But also the other thing here is that I honestly think that closed source models are genuinely more intelligent than open source models by a far margin. And I know that's kind of a controversial thing to say for a lot of people because there's kind of really two camps. One is like open source is going to catch up and hopefully surpass closed source, and vice versa. I would fall in a somewhat realistic camp that closed source models are way more intelligent and they will become more and more intelligent, and the gap will widen between open source and closed source. Partly because the modalities. And that kind of goes to this next chart. So if you look at the open source models that are available today on Hugging Face, there's a variety of different options here, and this text is really tiny, so it's hard to kind of call out. But the blue here is audio-based models, orange computer vision, purple is multimodal, yellow is natural language, and then red up here is reinforcement learning, and the blue is other. The one I want to call out is purple, multimodal. And you can see there's a really tiny proportion of the models here that are purple. And in my opinion, I think the most important models of the future are going to be multimodal. So they're going to be audio, image, text, etc., everything. And to build an effective model at that size, you're likely going to have a lot of money and a lot of compute. And sure, DeepSeek and others will be able to keep up with OpenAI and others in the US. But the question is, can they surpass them? Maybe they can. But I think that's going to be one of the most important factors that kind of dictates success in the long term for these models. And right now, OpenAI, or not OpenAI, open source struggles to do that. With that being said, my friends, this is the condensed version of a 340 slide presentation. I hope you enjoyed this. I hope you found it educational, entertaining, etc. If so, share it with your friends. And if you'd like to work with me, I have a company called Gradient Labs. We help other companies implement AI internally to automate processes, helping save time, money, and generate revenue. And if that's at all interesting to you, below is a link. You can book a call free for 30 minutes to see if there's a good fit between the two of us. And with that being said, Internet, I'll see you next time.